Good morning everyone. So welcome to NEET World. So in this session we are going to see JEE Mains PYQs of physics. So yesterday we have stopped with some questions, right? So from that we will start the questions today. And today's question is, yes, so this was the last question we have stopped, right? So the next question is, like two blocks are in contact on a frictionless table, one has mass m and other has mass 2m. Same force F is applied from left to right, left and right on m and 2m respectively. The ratio of contact force between them, between the block in the two cases will be. So they are asking what is the contact force between the two blocks, that means the normal force, right? So here let me take a diagram, free body diagram of the two cases. Yeah, this is the case 1 of having mass m and mass 2m. So when I apply a force F, and due to this 2m mass there will be a normal force here, that is n, right? Now so again in this case, no, due to this m there will be a normal force, so that is n. Now F is applied from this side, no, left to right, so acceleration of the block will be from left to right. This is my acceleration of the block. So the equation will be looking like F minus n is equals to m into a, and n will be equals to 2m. Okay, so no need to solve, no, I got n directly here. This is the normal force of the first case, n1 I will take. Okay, and if you see for the second case, like this is my free body diagram, this is mass m and this is mass 2m. So here force is applied, the normal force will be looking like this, n2, and one more normal force, this is n2, right? Now so acceleration of the block is from right to left, that is a. So if the equation is, like for this equation will be F minus n is equals to 2m a for the first one. For the second one, n will be equals to m into a. So this is n2, right? So n1 equals to 2m, yeah, what is this, 2m a, no, 2m a, and n2 is equals to m a. So if I want to write the ratios, no, n1 by n2 is nothing but n1 is 2ma divided by n2 is m into a. So here ma will get cancelled out. So the ratios will be n1 is to n2 is equals to 2 is to 1. This is my ratio of the contact force between the two cases, right? Now so option 2 is the correct answer. We will go for the next question. Okay. So in the arrangement shown in the given below, the strings are light and inextensible. The surface over which block are placed is smooth. What is the acceleration of each block? They are asking what is the acceleration of each block. So here in this case the diagram is given like 4 kg, 2 kg and 1 kg, and the force is applied, F is equals to 28 Newton. So the free body diagram looking like, yeah, the free body diagram of the 1 kg block. So 1 kg block, now first I will take the 1 kg block. So force is applied in this direction, F. So here the string is there, no, strings are there. So tension will be always away from the body. Tension is away from the body. This is T1 I will take, T1. So this is my direction of the acceleration. I am pulling the block in this direction. So acceleration will be coming towards me, right? Yeah, this is my acceleration of the body. Now what about the 2 kg block? I will write here, this is the acceleration. Now 2 kg block, no, 2 kg block, so there will be a tension away from the body T1, one more tension will be there. So, two strings are attached here. So, T1 as well as T2. So, this is away from the body. Now, what about 4 kg block? 4 kg block. So, only one string is attached, which is T2. So, these are the free body diagram of these 3 blocks. When I write the equation, F minus, like don't need to confuse that, wherever acceleration acts, no, that force you should take first, opposite forces are there, no, like tension, whatever it is, you should be taken in the negative. So, F minus T1 is equals to, mass is 1, acceleration is A. So, 1 into A. Okay. Next, T1. T1 is in the direction of acceleration, T2 is opposite direction of the acceleration. So, T1 minus T2 is equals to, mass is 2 and acceleration I don't know, that is 2 into A I will take. Next, T2 will be equals to 4 into A. 4 into A. So, from this I can add the equation, 3 equations. T1 get cancelled out, minus T2 will get cancelled out. So, F will be equals to A plus 2A plus 4A. So, 6 plus 7, 7A no, 7A. So, what is F given here? 28 Newton, right? So, 28 is divided by 7 is equals to A, which is nothing but 4, right? 4 meter per second square is the acceleration of the given block. So, whatever block if I consider, like each block having same acceleration, I am applying the force 28 Newton. So, acceleration of the each blocks will be 4 meter per second square. Option 2 is the correct answer. Okay. Can we go for the next part of the equation? Yeah. Okay. A 5 kg block has a rope of mass 2 kg attached to its underside. Okay. So, there is a rope here, but it is having a mass now. Okay. And 3 kg block is suspended from the other end of the rope. The whole system is accelerated upward with 2 meter per second square by an external force F naught. The question is, what is F naught and what is the force on the rope? Like what is the force on the rope and what is the tension at the middle point of the rope? So, exactly they are asking what is the tension at the middle point of the rope. Okay. So, first thing we will find what is F naught. I need to apply, like I need to find the force na. Okay, I'll take a pen. So, if I see here 5 kg, 2 kg and 3 kg, na? 5, 2 and 3. I can take with, they have given the acceleration also. So, acceleration is given as 2 meter per second square. So, F naught is equals to whatever the masses are there, like total mass 5 plus 2, 7, 7 plus 3, 10. 10 into acceleration is 2. So, answer is 20 Newton for F naught. First one, this is 20 Newton. Okay. I will keep as it is. For the second one, what is the force on the rope they are asking? No, force on the rope. So, only force on the rope. So, F is equals to mass into acceleration. What is the mass of the rope? 2. What is the acceleration? 2. So, answer is 4 Newton. This is 20 Newton and this is 4 Newton. Okay. Now, the thing is, what is the tension? What is the tension they are asking? So, let me take a point here, like this is my half of the rope and this is the block 3 kg. Okay, 3 kg. So, rope means there will be a tension, right? T. There will be tension T, and here the weight will be given 3 into G, no, weight na 10. So acceleration is towards up 2 meter per second square. So why here I need to take the mass of the rope also, because rope is having mass, right? 1 kg I should take. 1 kg. This is 1 kg. Okay. Now you can write it now. Yeah, you can write it. So T minus 4. Yeah, you can write it. T minus 4 into 3. No, this is I should take it 4 into 10, because 1 kg plus 3 kg 4 kg 4 into 10 I should take. So 40 is equals to, and 3 into 2 mass, sorry 4 into 2, right? 4 into 2. The total mass I should consider here. Here I should not consider only the block mass of the block. I should consider the total mass, like rope also having mass. So answer will be T is equals to, that is 8 plus 40. Answer will be 48 Newton. So this is the answer for the third question. I hope you got the answer na. So you can find like this also, like F naught we know, F naught is 20 Newton na, 20 we know, and yeah 20. So then here 5 kg plus 1 kg 6 kg. So the weight will be, weight will be there, and as well as the tension also will be there. So in these cases I will draw the diagram here. F naught is there, weight is there, tension also is there. I should take the tension as well as weight. So F minus W minus T is equals to mass into acceleration. So F naught no, minus, what is the total mass? 5 plus 1 kg off of the rope. So 6 into 10 minus what is this? Tension. T is equals to acceleration, no, 6 into 2. 6 into 2, and this is F naught. Okay. This will be my equation for when I take the upper part of the free body diagram. Okay. Can we go for the next question? Okay. Find out the contact force between 2 kg and 4 kg block as shown in the figure. So contact force they are asking, right? Contact force. So what I should do here? Yeah, I'll take a pen. Yeah, fine. So here in this case, I'll take a diagram in this manner. So this is my normal force and this is my weight, na? That is mg, right? So if I take the angle theta here, this is my mg cos theta and this is my mg sin theta, So there will be a normal force in this case, and here also one normal force will be there, and there is normal force here also, right? Now one normal force, two normal force and three normal force. So we are talking about the normal force in between these two blocks, So this is mg sin theta means, and the force, like find the contact force, that's it. So object is moving in this direction, I will write here. So this is mg sin theta, this is my normal force, and here also one normal force is there, n, right? No, n, and acceleration is in this direction, block is going towards down. Okay, theta is given 37 degree, so mg sin 37 minus n equals to m into a. Okay, so here we know that acceleration is nothing but g sin theta, acceleration g, a is equals to g sin theta, right? Now, yeah, so I can find here mg sin theta minus n is equals to m into a, and n is equals to 4, no, this is 2 into a, 2 into a and 4 into a. So from this I can find what is the value of a first, and I can substitute either in the second equation or first equation. I will get the answer for the question. Okay. And if anyone is asking what is the acceleration if I take only 2 kg block and if I add one more 4 kg block, acceleration will be remains constant there. So a will be equals to g sin theta. Yeah, Niklesh, which doubt you have? Which one, madam? Which one? Yeah. Yeah, Niklesh, you can tell me which doubt. Okay, fine. We'll go for the next question. So here is the next question. Two blocks are kept on a smooth fixed slope as shown in the given figure. A 2 kg block goes down with an acceleration of 2 meter per second. The value of m they are asking. So this is the value, like this is the thing I need to find here. Like the value of this block I need to find. Okay. So if I take, this is my mg sin theta, right now 37 na, mg sin 37, and this is my mg sin 53, right. So a tension will be acting here, T1, same string, same tension, T and T, okay. Now the block is going in this direction, they said, like with 2 meter per second square. So the equation will be mg sin 37 minus T is equals to the block, like m1 I will take m1a, okay, m1a, and if you see here T minus m2g sin 53 is equals to m2a. So these are my two equations of this diagram. So from this, if I add the thing, T and T will get cancelled. M1 is I know, M1 I know, M1 I know, M2 I need to find it, right. So from this equation I can find M2, right. Yeah. So I will tell you trick here to get this mg sin theta over here. Okay. See, whenever you are getting a diagram like this, na, take 8 parts like this. Take 8 parts like this. Theta is there, so exactly you place the theta here. Okay. So give, like you should place the theta alternatively. So you will get 4 thetas, no, 4 thetas. So here if you see the theta, no, this is my mg. Exactly I will draw the mg like this, na, mg will be like this. So this is my mg cos theta, mg, like theta is near, so mg cos theta. So this is my mg sin theta, no, mg sin theta, mg sin theta. You can remember this diagram whenever you are having an inclined plane, so that you can able to easily find the thetas like mg sin theta or mg cos theta values. Okay. So similarly for this also. For this also I can place over here, right now, place over here, theta will I should take in alternatively, and mg cos theta and mg sin theta will come. Okay. So we will go for the next question. Yes. So in the system shown in the figure, all surfaces are smooth, string is massless and inextensible. Acceleration of the system I need to find, first thing. Tension in the string I need to find. Extension in the spring if force constant of spring is K, which is 50 Newton per meter. So this is the spring over here and these are the tensions, right. So if I take the free body diagram of this figure, yes. So for the 1 kg block, only the tension is there. So block A, tension is there, that's it. Okay. So obviously 2 kg plus 3 kg, 5 kg is 1 kg. Obviously the block will move in this direction. Excuse me. Yeah. Next, if you go for the block B, this is block B where the tension is away from the body T, and one more force is there, that is spring force, na, Fx, no. So I mean K into X, na, F is equals to Kx. So this is, I will take spring force, okay, and weight also is there, weight of the body is there, no, weight of the body is also is there, which is WB. This is for the body, I mean diagram 2. So next is block C, this is having spring force F, yes, okay, here the weight also is acting WC, that's it. So now you can draw the, like you can write the equation of this given free body diagram. So T is equals to mass is given 1, acceleration is not given, no, I need to find the acceleration. So 1a, so a, that's it, T is equals to a, and in this case W plus Fs minus T is equals to, what is the like mass 2, so 2a. Equation number 1 is T is equals to a. Equation number 2 is weight plus spring force minus tension equals to 2a. And equation 3, weight is downwards. This is WB, this is WC. Weight is downwards and the spring force is opposite direction. So Fs is equals to 3a. So I can add this equation, plus T plus F minus F will get cancelled. So W, like weight, what is the weight? 2 kg. 2 into 10, 20. 20 plus 30, 3 into 10, 30 is equals to 3, 2, 5, 1, 6. Right now? Yeah, 6a. So A will be equals to 50 by 6. A will be equals to 50 by 6. Now you can substitute the value of A in any of the equation. I can find the value of tension. So take the A, substitute in equation 1, I will get the value of A, I mean tension. So I need to find the value of F also, either in the first, second equation or third equation. Okay, I will find the value of F. Okay, we will go for the next question. So the speed of a boat is 5 km/h in still water. It crosses a river of width 1 km along the shortest possible path in 15 minutes. The velocity of the river they are asking. The velocity of the river. So I told you to keep in mind two cases, shortest distance and shortest time. So here they have given that it crosses a river width along the shortest possible path in 15 minutes. Shortest possible path. So it's making an angle theta and it's going. Okay, this is velocity of the river with, velocity of the man or boat. Boat is given, boat with respect to river. This is velocity of the boat with respect to ground, velocity of the river with respect to ground. That's it. Now we can write the angles like sin theta is equals to opposite velocity of the river divided by hypotenuse velocity of the boat with respect to river. Cos theta is equals to adjacent by hypotenuse velocity of the boat divided by velocity of the boat with respect to river. Okay, and tan theta I can write like tan theta also is nothing but velocity of the river divided by adjacent velocity of the boat. So in this question they are asking velocity of the river water. So they have given velocity of a boat 5 km per hour is still in water. So which is nothing but velocity of a boat with respect to water is equals to 5 km per hour. So either I can use to find velocity of the river is sin theta or tan theta, and the boat with respect to river is given. So I can use sin theta, right? Directly I can use sin theta. So sin theta I can, velocity of the boat with respect to river sin theta is equals to velocity of the river. Okay, but one thing is given like angles we don't know, right? The theta I don't know. So I can use like which one I can use? I can use this equation itself and I can find time is equals to distance by velocity. What is width is given 1, that is displacement is 1, velocity is 5 km per hour. So I can find the time, and if you take the time, find is given like time is given, no. So this one, see here, velocity of a boat with respect to river I can find easily. Yes, velocity of a boat, velocity of a boat with respect to river is equals to velocity of a boat into cos theta, right? So time is 15 minutes, which is nothing but 0.25 hours. Okay, divide by 1, distance and the time is equals to velocity of the boat. That's it. So here how much? 1 divided by 0.25, no? So into 100. Into 100 means it will come 100 by 25. So velocity of a boat is nothing but 4 km per hour. So take this value, substitute in this equation, you will get the angle. I know velocity of a boat now, velocity of a boat with respect to water also, river also I know, I can find the angle theta. So what is the angle theta? So it is 4 divided by 5. So I can get the value of 5337 354. So 4 by 5 4 by 5 adjacent by hypotenuse cos, so 37, angle is 37 degree. Now I can find easily this one, velocity of a river. So 5 into sin 37 is sin 37 opposite by hypotenuse. So 3 by 5 is equals to velocity of a river. So 5 will get cancelled, answer is 3, option 1, that's it. Option 1 is the answer. So you need to understand the diagram first and write the sin, tan and cos. So from this whatever they are asking I can get it, right. So with this we conclude today's session and we will get more questions in the next session, guys. So thank you, until then, bye bye.